Okay, the last video I showed you how to find the determinant of a 2 by 2 matrix and of a 3 by 3 matrix. So this time I'm going to use those same determinants to also find to solve for x and y using Cramer's rule, or x, y, and z. So a 2 by 2 matrix means that we're dealing with x and y. Cramer's rule, it says essentially that you're in the form of, when you write the matrix equation, a1, a2, b1, b2 times xy equals c1, c2. That's how it thinks that you're in when you're using Cramer's rule. So you already have it in the matrix equation. Now what you're going to do is you're going to say x equals this matrix right here, c1, c2, b1, b2, over the determinant of your original matrix. Y equals a1, a2, c1, c2, over the determinant of your original matrix. Now notice that the parts that I replaced with c are the parts that I'm trying to solve for. If you're looking at your original equation, it's going to be 2x plus 3y equals 5. Something in this format right here. 2x plus 4y equals 6. So you're looking at something in that form. So when you write the matrix equation for this guy, it's going to tell you your constants, your coefficients times your variables equal your constants. So if you look at this, your A column are really your x values. And in this one we're trying to solve for x, so the A is replaced with the C column. Your B column are your y's. And in this one you're trying to solve for y, so the b's are replaced with the C column. And I'll show you how to do that, okay? So let's write the original matrix right here. Let's find the determinant of this guy. The determinant of this guy, remember, is a times d minus b times c, which is 2 times 4 minus 3 times 2. This is 8 minus 6, or 2. So that's what our determinant is, which is going to go in here and in here. I'm going to rewrite my equation with the numbers in. So C1, C2 is 5 and 6. B1, B2 is 3 and 4. I don't know why I put it as a fraction. Pretend that this fraction bar is not there. Over D, which is 2. Y equals A1, A2, which is 2 and 2. C1, C2, which is 5 and 6, over D, which is 2. Now you're going to find the determinant of this top part, which we're going to get by doing 5 times 4, or 20, minus 6 times 3, or 18. 20 minus 18 is 2, so x equals 2 over 2, which is 1. You're going to do the determinant of this guy, which is 2 times 6, which is 12, minus 5 times 2, which is 10, equals 2. So y equals 2 over 2, or 1. I usually like to write my answers as a point, so I'm going to put 1 comma 1. And that's it. I'll do another example right now, just to reiterate the fact of what we're doing. So if I start my equation as, and hopefully it doesn't give me some crazy numbers because I'm just coming up with these off the top of my head, but it probably will. So I'm going to write the matrix equation first. Coefficients times variables equal constants. Now I'm going to find the determinant of this first matrix, which is 3 times 5, or 15. minus negative 4 times 2, or negative 8, which equals 23. Minus a negative means I'm really adding, so 23. I'm going to write my new matrix, x equals, remember your x values get replaced with your c's, so it's 17, negative 1. Your b values, or your y, stay the same. And this is over your determinant, which is 3. For y, your x values stay the same, 3 and 2. Your y values get replaced with the constants over your determinant, which is 23. So now I have to find the determinant of this guy, which is going to be 5 times 17, or 85, minus negative 4 times negative 1, which is 4, which is 81, over 23, and that's what x equals. Find the determinant of this. 3 times negative 1 is negative 3, minus 17 times 2 is 34, which is negative 37, over 23, which is y. I'm going to write it as a point, 81 over 23, comma, negative 37 over 23. And that's our solution for this equation, for this system of equations.